Previously, we used a while loop based solution to solve the subarray sum problem using the sliding window. So the idea was we put a while loop while right less than n. Inside this loop, we go and update the window sums and update the maximum. The most interesting part of this code is, to me, as a, let's say, from a learning point of view, is that the pointers movement is explicit. So we can clearly see right is moving by one, left is moving by one, and that makes it kind of somewhat easier to understand. There is, in fact, another way to write this code, and that goes with using a for loop. In fact, we can write for loop for left or for loop for right. Although for variable size window problems, as we'll see later, right is in fact a more natural choice. In these implementations, one of the pointer moves as part of the for loop, and the other one has to be moved through the code. Now, once again, coming from an intuition idea to a code is always something that requires a lot of care, and we are going to do that again over here. So we have to see this code carefully. We have to code this carefully so that we avoid mistakes, let's say the corner cases. In fact, the thought process is quite similar, whether we use a while loop or a for loop, but it's interesting nonetheless to look at this because these coding styles can help us in general. So let's look at this solution with for loop on the right pointer. Notice I am basically, assigning my pointers in the beginning. I'm finding the first sum like usual. Now here I'm saying right goes in a for loop from range k to n. Remember, right has been set to k. Basically, this is exactly same as saying that, look, right is going to be k plus 1, k plus 2, and so on and so forth until n minus 1 because range is k n. And which is logical because remember, right is telling the pointer that is coming into the window, and the largest value right can take is n minus 1, exactly why we had put while right less than n. Now, everything else remains exactly the same. I increment left, but since I have incremented left earlier, when I do the assignment of the maximum, I will assign it to left. Now, of course, I could have put this assignment before, in which case, my left would have become left plus 1. So, the logic is important. Implementation has to just follow correctly, right? So, since in this case, I'm increasing left over here, I just, return left. Now, same way I can do this code on the left side. So here, notice my left goes from 0 to n minus k. Once again, this makes sense because remember the last subarray starts at n minus k. However, this left here is telling you the pointer which is leaving the window, which means we are looking at the window, the pointer that was leaving the last window, which is n minus k, that has to be at n minus k minus 1. Think about it, because the window still starts at n minus k, so the pointer that's leaving has to be at n minus k minus 1. Once again, we have to be careful. Apart from that, everything remains exactly the same. In this case, left moves with the for loop, right is something that I am explicitly increasing. Now, because left is still pointing to the one that was leaving, hence I must go left plus 1 over here. Again, like I said, these little details are important. We have to think through them carefully. In this case, right is moving through the for loop, left is being moved explicitly. In this case, left is moving through a for loop, right is being changed explicitly, but the code intent is otherwise exactly the same. We have implemented both of these, in the code over here. So this is my first alternate solution, for loop on the right. Notice my right is moving in the range kn, and here, since I'm doing left plus equals to 1, I am sending a left over here to index max. But of course, like I said, if this if statement had been put before this assignment, then we could have just written left plus 1. So, this code works. When I do this, for example, on this list, it tells me the max sum is 7003 because I've artificially jacked up these numbers. Likewise, if I look at, let's say, the second alternate where I'm running a for loop on the left side, well, this time round, the for loop is running on the left. Once again, think through why this range. But other than that, everything remains the same. Remember, left is the pointer that's leaving, and hence I return left plus 1 here because that's when the window is starting. And again, I tried this code previously. The same exact, answer is what I adopted. Now, one thing I just want to highlight is that, when you write this code, it's very easy to make mistakes because these things are kind of, let's say, a little bit hard, all these boundary conditions. So while writing a code, a useful strategy could be to just keep printing, for example, the current sum, right? So I can just show it over here, current sum, right? So basically, remember, current sum is the sum for every subsequent window. So basically, notice in this case, my first sum that was formed is outside the for loop in this case. So that is whatever it is. But next I have, for example, 157, that is this. Then I have 51. Oops. Then I have, let's say, 51. Then I have 5 plus 6 is 11, minus 8 is 3, and so on and so forth. So this, if it's all working correctly, most likely things have been set up correctly, right? So think through this carefully. This is a useful trick. You can use it in any implementation. It's good to look at all these different, let's say implementations, because these ideas can then be used in other problems as well. I hope you found this interesting. Look at our website www.ybyte.in. We always look at problems in a very careful, deliberate, step by step manner, and we have fun activities through which we enjoy programming. Take care. Thank you so much. Bye bye.